Hello, everybody. Thank you for joining today. I know it's a little bit of a change of plan, and we're now doing this virtually, but I'm glad you can join me on my talk today. So, I also know it was originally planned for Paul still do a talk, but unfortunately, with the current situation, Paul couldn't make it. So, yeah, apologies about that. So, what we're going to talk about today. So, I have a little talk lined up, and it's based on a past experience at a previous company. So I'll try and explain the title a little bit. So we have database deployment cowboys to continuous delivery heroes. So it's probably worth pointing out to start with. I was probably the database deployment cowboy at the time, um, and tried to turn myself into a continuous delivery hero. And we'll talk a little bit more about that and where we started with our database deployments and uh, where we got to um, reduce production deployment issues. So before we kick off, a couple of things I just want to go through. So if there's any questions, head over to slido.com. Use the code which you can see on screen at the moment, Y860. Um, put your questions in there. If any of the questions that pop up during the webinar or this talk fit into where I'm at, I'll pick those up. But I've left some time at the end to go through any kind of questions that you might have. So, um, next one. So, while I'll talk about my previous experience with database deployment, we also have on octopus.com a database deployment blog suite, which goes right from the basics of database deployment all the way through to complex deployments, and that's not just related to Octopus. That's covering all different kind of tools that you could use to and different methods to deploy your database. So a little bit about me. I'm a continuous delivery architect at Octopus Deploy. I am responsible for mass learning at Octopus Deploy. So that's delivering talks, writing blogs, and mainly helping our customers use get the most of out of our software. So my background before joining Octopus, I've had quite a few job roles now in the software industry. Started straight after school at 16. First of all, started on support, supporting all different types of software products, and then I moved into software engineering. Basically, a background in C Sharp, .NET, MySQL, SQL Server, and all those kind of technologies. And then I I took an DevOps engineer role. I got really passionate about automating all things software. I used to see previous companies just doing manual tasks all the time, and it was just something in me that I had to try and help automate. Whenever I saw somebody do something manual more than once, um, I had to kind of jump in and help automate that. So yeah, I've got on the slide there, automation lover, and it's kind of good fit that I'm actually working for Octopus now. So the agenda today, I'm going to take you through my database deployment journey. So where at a previous company where we started with our continuous integration deployment pipeline, and mainly focusing on the database side of things. How we started with running manual changes into production without any kind of automation, and how that led to uh, numerous issues reported by customers and monitoring software. I want to talk about the dream scenario, where we got to. Um, what we're going to do is include what I've done is I've kind of recreated our scenario of how we actually deployed our database changes. So I'll take you through that demo and take you through all the tools that we used. And then at the end, we'll go through any questions that you might have. So, my story. So, I I was working as a an engineer. I was working on the code. Um, I was working for a healthcare company in the UK. So I was providing software to the NHS market. We sold our software to GP customers, GP practices in England, and healthcare organisations such as a hospital. We were going through a phase of redesigning our desktop software to be a SaaS application, and we were using .NET MVC, C Sharp to build that application. So we we had the job of migrating on-premise databases into the cloud, but that's probably a story and um, a lot of other complex challenges for another time. But to the database we were using to host our .NET MVC application was MySQL Enterprise. But the tools that I'm going to talk about today can be used with MySQL, SQL Server, Postgres, a variety of different databases. So if I kind of set the stage a little bit, it was so this this story kind of originated in 2016, kind of ended in 2018 when I left the company. I moved from an engineer role to DevOps manager. Now, I think DevOps manager as a title can be somewhat confusing, but I was kind of responsible for um, automating our software delivery. So we were deploying um, once a month, and it wasn't frequent enough, and we needed to try and increase that. Now, the reason why it was taking a couple of months when I joined, so we were deploying our applications to a private data center, IaaS, infrastructure as a service, basically. And to actually deploy our applications, even though this was 2016, we were just basically taking a build off a local developer machine, taking those files and copying and pasting them onto each IaaS server. Now, in this for this application, we had a web farm of servers. So we were taking down a server at a time, copying files on, taking the next server down, again, copying the files on. And then also the same kind of principle for the database, taking the scripts that each developer had created for a particular release, and then running those into development, test, and production. It was a very lengthy process. We could have the application down for depending on amount of SQL changes that we were migrating at the time. It could take from a couple of hours to 8 hours, and this was done during the night. We were paying on call hours for the staff that were actually undertaking that work. So it was a very costly exercise, and it wasn't a good experience for the customers. We wanted our software online 24/7, and we were taking that down, although it was only once a month. It was a long period of time for the software to be down. So at the time, we were expanding the development team as well. So we're hoping to get more and more changes, new features into the software. So when I started, obviously it was clear we couldn't keep copying files and SQL changes manually into development, test, and production. So I first started looking at ways of automating that. I first went down the road of writing my own PowerShell scripts to automate the delivery of the software. That was going to take me far too long. So that's when I came across Octopus Deploy. So we started using Octopus Deploy to automate our software delivery. Now, if anybody doesn't know what Octopus Deploy is a software deployment DevOps tool that's going to take any of your software packages and deploy those to your infrastructure. So After 6 months, we managed to create first of all a central CI build server. So we had all developers checking in code into GitHub and TeamCity, uh, building that software, pushing packages into Octopus Deploy, and we were actually delivering that software out to all our machines in one go. So taking deployment times down from um, 8 hours to 10 minutes. And we were actually managing to deploy more frequently. So I think we're up to a deployment every once a week. So the problem that we encountered, we managed to automate the delivery of the software, but nobody really considered nobody. We did consider the database, um, but there were strict rules around around how we actually deploy our database changes. So basically, how we were deploying production, development, test, and production SQL migration changes. So basically, a developer would create a new SQL script to change the database for a particular version. It would hand that script over to the DBA. Now, it was very important at the time that the DBA reviewed that script, make sure it was optimized, and he would actually run the changes into the production database. Now, again, that was another blocker for us. Having a DBA have to review each script and then deploy those into production. It was just another blocker really, and it wasn't automated enough for me. Having some kind of manual intervention or a human needed to be on call when we deploy a production to a production environment. It just obviously it didn't sit right. So we kind of moved on to how we could automate the database. Now, that wasn't the only problem. The only problem wasn't just deploying to production. So each developer had their own local copy of MySQL on their machines, and that's what they'd work off. Now, even though they're supposed to let you know that they've changed the database and then pass that script on to the DBA, and then the DBA has it, he can check it, and he can deploy that into production. Now, we were finding that wasn't the case. Somebody would make a quick change to the database. It wouldn't get it wouldn't be sent to the DBA. We deploy to production, and then the next day or a couple of hours later, it was the case that something's broke, and 50% of our production deployments broke because of a missing schema change or standing data change. And it wasn't just a production database that was causing the problem. If we were onboarding new developers, or developers were pulling code from a repository, they wouldn't know what each developer had changed in their database. They'd go to start debugging the code, realize they're missing tables, and then there's a big conversation to work out, well, who added this table, who's added that one, who needs this column, and it just kind of slowed the whole development time down, and we weren't getting enough work done in a sprint. A developer would be spending a couple of hours a day just trying to work out what change do you need in his database. So it was also about trying to improve that process as well. So there was I was getting a bit of a pushback on how I try and automate this, because there was a big fear and a big trust issue with automating database changes. Now, the trust issue came from a DBA should always review the scripts, which I still agree with. But a DBA should then be the one that runs that into production. We needed to kind of remove that, so there wasn't trust that the developers could a tooling could actually run these changes in for us and expect it to work in production. I'll take you through the demo on how we kind of we kind of got over that. So first attempt at trying to work out a better process. So it was a case of if a developer had changed the database, we would add that to a Slack channel. We had a Slack channel for database changes for each of our products. Developer would add that in, and then in there, the DBA would pick up that change and add that to its list of SQL changes to review, and then ensure that got into production. It did help with so it did help with all the other developers wondering what change had been added in. They'd see a notification in Slack to say this particular database has been changed by, say, Joe Blogs. He then can get that database and then run that into his local database. However, again, it was still the same problem. Sometimes it's 5:30 p.m. Developer on a Friday, the developer's just about to go home. He's not remembering to add his SQL changes into Slack. And again, we still had missing scripts from production deployments. And again, it kind of solved some problems, but not them all. So next, we still added things to Slack just to notify people that certain columns and objects were changing in the database. So what we started to do is actually compare developer local databases to development, test, production. Now, but before deploying to dev or to the development environment, we could run a compare against the developer machine, compare that to the development hosted solution, compare that, and then any changes that were missing, we'd run those into each environment. And then the same goes for production. So at the end of each sprint, we're about to deploy a version. Each developer would compare against a production database, generate a schema change SQL file. Again, DBA would review that and then push that into production. This was very time consuming, having each developer to compare their local database to dev, test, and production, and then getting the QA guys to run those changes in, and then also obviously having the DBA run those into production. It was very time consuming. So we kind of removed that as an idea. It was a nice attempt, but I still felt we were shortcutting a dream scenario, and we were still trying to, for some reason, to get away with doing this correctly. So it still didn't sit right with me. So we spent some time. We looked at tools out there that could help us do this, and we knew that it wasn't just going to be a tooling issue. It was also going to be it's going to be a trust and a people problem that we need to overcome. So it's just something I've probably just missed. It's probably just worth noting. It wasn't just a kind of a production deployment that was breaking our deployments. Whenever we wanted to find out who or what had changed in a database at a particular time, we had no transparency. And even with the compare, we still had no transparency. So one of the things we were aiming for is to have full transparency, just like we do with code. You make a change in the code, you commit that to source control, it's in GitHub or Azure repos, I can go back and I can find out. So if I'm looking at a bug, I can go back and find out who changed what, and trying to pinpoint the issue quicker. We didn't have that with database changes, so that's another kind of thing we were trying to hoping to get out of our dream solution for deployment migrations. So tools that we end up using to get us closer to the. I still don't think we got to the dream solution, but we definitely got us underway. And we used a combination of Slack, DBUp, Octopus Deploy, and TeamCity. Now, for anybody who doesn't know what DBUp is, what I'll do. So DBUp, essentially, it's a .NET library that helps us deploy migration scripts. So you can build DBUp as a console application, and you basically add scripts to the console application package. And I'll show you that in a second in the demo. DBUp will run those changes into your desired database, and it'll leave a log of what changes it's ran into which database, so it knows not to run those SQL scripts in a game. But you'll see that a bit more clearly in the demo. We use Octopus Deploy to deploy the software, and we also use Octopus Deploy to trigger the DBUp package to actually run the migration scripts in. And we had TeamCity building our source code, building packages out of that, and pushing those into Octopus. So what I want to do, I'm going to just jump into my virtual machines. Actually, before I do that, it's probably worth. So during this demo, I'm going to be deploying Octopus's Octo Pet Shot sampling application. There's this a sampling application that you can actually get off our GitHub samples website. I'll grab that link after, and I'll share that. So if anyone wants to use this to test anything, you're more than welcome to use it, as it's public. So I've got a .NET. This is .NET Core application with a SQL Server backend, and it's basically an application just to display some pets for a pet shop. We have our development environment here, our test environment, and our production environment, and that's actually just sitting. So they're all hosted with Azure Web Apps. So if I just go back into Visual Studio. Just going to move my face out of the way. So you can see this is the Octo Pet Shop solution. We've got the web app there, some tests, some unit tests, a product service API, and some other projects that we're not going to be using today. But you also have the Octo Samples, Octo Pet Shop database. So this is our DBUp project. So what I'll do before I just jump into and start changing that, I've also got TeamCity here, which is basically connected to my personal GitHub repository, which is going to pull any changes down I do and build that, and then push them into Octopus Deploy. And then we're going to see that application get deployed out through development, test, and production. So what we've already got at the moment in the Octo Pet Shop database, we have two SQL scripts. So what you can see that these are labeled incrementally. So 001, 002. So any changes that we want to make, we always label them with a number so they get ran in a particular order. So if I go into create table, so basically this is just our initial database creation. So there's only one table for Octo Pet Shop. So you can see here it creates table, ID, image URL, price, and stock. And then the second SQL is inserting some standing data in there for us. So if we go back to Octo Pet Shop, we can see that that's the data that there it's actually presenting. So going back to uh, how how we wanted this to work, we wanted our developers to create a script um, inside here, and that will get checked into source control. Um, at that point, they do a pull request. In that pull request, we'd have a DBA as a reviewer. They would review that, and then that will get committed to uh, your master branch or your develop branch, whichever branch you're working on. So I'm going to do, uh, I'm going to create a new script. So I'm going to do it very simply today, just to keep it simple. I'm going to add a new product into the database. So simply come in here into scripts. I don't know. Oh, so I've got my face from Zoom blocking the screen. Add new file. So again, I'm going to create this. So it runs in order 003. So let's call this create product. No, let's new product and oh, I can spell it right. There we go. And we'll have a new pet called octopus. So .sql. So we need to write the script. So what I do, I've actually got. Be easy if I just take a copy of that rather than typing it all out. Let's get rid of that. So let's go change these values. So I'll have this octopus. I think it's going to be a nice octopus. I see the URL to get an image. I have one here. We could change the pricing in stock, but I'm just gonna leave that standard for now. So we are going to run. We want this script to run on all our environments. So this is going to come out of the norm a little bit. Normally, what you do at this point, you've added a new SQL script. You change the code. You're going to do a pull request, and you're going to get a couple of reviewers, somebody to review the code and somebody to review the new SQL change that you've added. I'm just going to shortcut that for now. I know you probably won't do this in real life, but I'm going to commit directly to the master branch. So I'm just going to use Visual Studio to do this. So I'll definitely put a comment in there. I don't want to wonder what I've committed. So I'm going to do a commit. And what I do is do a commit all and push that to the remote repository. Save that. So let's make sure that actually goes out. Yeah. So pushed. Okay, so in a second, we should see Team City build this package. So if I go into, should start seeing that come through in a second. So I've basically got a hook just watching for my GitHub repository for any changes committed. So I think it runs on a timer, I'm not sure. So that's gone. Keep one off in a minute. I'll keep it off manually in a second if it doesn't go through. So Oh, mind the yeah, there we go. So it's actually building that now. You can see that's going to build. So I'll just quickly go through. I'll just take you through what steps it's actually doing. While that's building. So I did a publish on the web, the API, and the database. I'll just take you into this step. So it's just packaging this up. Just packing the project up using a publish command from using .NET CLI. So I've got back to the build steps, and then we're packaging the database up ready for Octopus deploy, packaging the website up and the API, and then lastly, what we're doing is pushing the packages to Octopus deploy. But we're also creating a release, and TeamCity is automatically going to create a release for me and deploy it straight to development. We should see that in the agent. Yeah. So you can see got a new version, 2020.3.35, currently being deployed. So if I just jump into there, so we're not supposed to deploy now. Let's go into the task log. So what's happening here? Octopus Deploy has deployed the database package to a SQL jump box. And what happens there is Octopus Deploy deploys the console application, runs a PowerShell script to run the package. And what DBUt's going to do, it's going to use its connect string to deploy the new script I created into the relevant SQL database. So I want to deploy to my development SQL server. Oh, that's actually the wrong one. So you can see here, deploying the package, checking whether the SQL scripts already exist. We can see here it's executing the database server script, script 003, new product octopus.sql. It's actually deployed my products API and web app. All I do is just load that up. We should now see the octopus product being added. Give a second to load. Yep. So if we'll just double check before, which I wasn't in, you see that's the previous version, and we deployed the new change, which now includes the octopus, but a nice octopus. So that's all. That's cool. One of the great things about the script-based approach of running your database changes is we want to ensure whatever gets deployed to development gets deployed to test, pre-prod, and production. Whatever environment you've got, we want to ensure that the deployment is repeatable and reliable. We want to ensure that the scripts that have been ran in development are also ran in test and also in production. And this is a good way of doing this. So before I start deploying it out to test and production, if I just go over to my GitHub repository for Octo Pet Shop and go into commits, one of the things that I mentioned, it was about transparency. I can come here and look at all the commits and see all the work we've done on this code and try and establish any bugs or just looking for feature requests that we've changed. And come in here, I can see this. I've added this new script, and it's going to tell me what script was inserted and by who, so we can kind of understand maybe why a column was changed or a new table was created, or if there's a bug, we can easily pinpoint it back to a particular change. So using this script based approach and storing this in source control really helped with transparency. So I'll go back into Octopus. So we've now run those changes in development. And I know this works now in development. So I'm fairly confident that it's going to work in test. So go ahead, I'm deploying the same changes, the same package that I built, but deploying to test instead. So any kind of failures that we were getting in production before undertaking this work to improve our database migrations, we're actually spotting these issues earlier in during deployment or development, because the same deployment I do in development is happening in tests and it's happening in production. So we can see here, um, again, we've run the DB up runner on the test environment, and it's executed the same SQL script, and it's deploying our application out. So let that finish. Success. You can see, you can open that up. Again, we've got a successful deployment. It's run the same changes in development, in test as what it did in development. So when it comes to deploying to production, I am almost certain. It's not always the case, because you always get something that crops up. What somebody's changed something on the infrastructure that's going to break our code. But I am fairly confident, because I have had a successful database deployment to development test. It's gonna it's going to work in production. So let's actually see. Um, let's hope the demo gods are with us today, and it actually does deploy. So actually, very worth noting. So in Octopus, before deploying to production, one of the things that we had, even though we had DBAs reviewing pull requests, it was always nice before we deployed to production that someone just signed off a release. It doesn't have to be a DBA. It could be a release manager, or it could be your exec team. Just say, yeah, we're happy for this deployment to go out. Octopus gives us a nice little step to do that. So I was going to sign up to me. Okay, to deploy. Proceed. And that's going to go through the exact same release steps. So just quickly, these are the release steps. Got an approved deployment. We're deploying a database package. We're deploying a product API, and deploying a web app. So everything that was deployed to development tests is happening into production. So that's just kicked off now. I'm going to deploy the database again. And let's run the, go in, say, execute that same SQL statement. And it's just going to deploy my web app to Azure. It should take a second. I go into here. I should have another successful deployment. Although the script is relatively simple, that script shouldn't really break any production deployments. But if someone's mistyped a script, still any script can cause an issue. And it's more just to demonstrate the process. Hopefully this loads, and we have the new Octopus product in our pet shop. There we go. So this is the stage that we got to. Again, just to recap on what it actually gave us. We had repeatable deployments, which was key for us. Whatever was getting deployed, whatever package was getting deployed to test, development and test, and the QA team or the test team had signed off. We knew that package was going to production, so we were fairly confident that the production deployment was going to work, and we saw a massive reduction in breaking production deployments because of SQL changes. It was enforced that all developers had to put their SQL changes into DBUp, into the solution file, into the scripts folder. Sorry. And so it was it wasn't a case of just tooling. It was a case of getting developers to maybe come out of ways that they're used to working and changing that. What how it helped with our developers pulling down the latest code from the remote repository was every time somebody did a pull from a particular branch, uh, it always ran the Octo Pet Shop. Well, not Octo Pet Shop. It always ran the database project. It did a check, and it worked out what scripts needed to be run, and what didn't. So there was no more pulling code down and tables missing from a particular developer's database machine. So it definitely solved that problem for us. It gave us the transparency through source control to actually understand what changes have been run in. So making bug fixes or bug investigations easier. It was just easier to find changes that happened in the database. Um, the biggest hurdle to get over um, was putting the trust into automating database. You know, it's the classic of all SQL scripts need to be sent straight to the DBA for review, and it was kind of DBAs were thinking, well, okay, if you're going to undertake this, going to automate it, and I'm not going to run these, if I'm not going to be responsible for running these changes into production, where do I fit in? And it kind of got the question of, is it, are we taking a DBA out of his job? And it was absolutely not the case. The DBA still plays a really important role. It just meant rather than getting the scripts via Slack or um, via an email, they would be reviewer in GitHub. So when a change was checked in, the DBA would still review on many occasions, change the SQL so it was more optimized. He then, once he'd reviewed that, committed it. He just wasn't responsible for adding those changes into production. And when we kind of got trust from the DBA and you know um, people higher up in the company that um, the automation was going to work, and it was going to be repeatable and reliable. It kind of took off, and we didn't really look back. It really helped us improve our time, um, our production deployment time, um, and it cut down a lot of out of our staff costs as well. We didn't need to have the DBA waiting, um, at 12 a.m., 1 in the morning to actually run these into production. We were so confident that we deployed to development and deployed to test with the exact same packages and the exact same scripts that we could trigger off a deployment at night without anybody overseeing it, and just having an alert in case anything went wrong. And we already knew that the DBA had reviewed the changes, so we were fairly confident that the SQL changes were good and ready to go. So that kind of wraps up uh, the demo part of it, and where we got to. So one of the questions that that we get a lot at Octopus. This kind of story doesn't really discuss s- ro- version rollbacks. Okay, I've deployed to production. Something's gone wrong. How do I roll back? So this is the question that we get at Octopus. So can Octopus deploy do rollbacks? Um, yes, it can. However, all comes back down to the database. The database is the biggest blocker when it comes to rolling back, and it is another complex topic. But I can go into Octopus and deploy a previous version back out to test. But also, it depends on how you've structured your database changes. Now, you've just seen me there commit a change and deploy that straight out. Uh, you need to kind of, if you want to ensure that you can roll back to a previous version, you need to ensure that your database changes are kind of running into the future. So if you're creating a new column, create that new column, deploy that out with the old code, make sure it's backwards compatible with the old code, and then on the next release, deploy the new code to work with the new column. Um, and there are many different ways of doing that, and there are some good blogs in the link that I shared at the start, and I'll try and send that out afterwards as well regarding rollbacks. And it's still based on the same process that I've just shown you, but just a different way of or different. It's more about the timing of actually committing those scripts into production. So, but if I'm honest, my go-to on rollbacks is even if you can do it, um, don't. But that's my personal opinion. I think we're at a time now where with continuous integration, continuous delivery, where we're trying to deploy more frequently. So if we spot a an issue, I always tend to push to roll forward. Let's get a fix out, fix it, and deploy that out to production rather than rolling back. Because I've been in a situation where I've been pressured to roll back before, and I have, and it's caused more issues than and it's cost us more time fixing the issues of the rollback than what it would have been to actually just investigate the issue and fix it. And because we are deploying to development and test, and it's the same package anyway, we should be confident now when we deploy to production that everything's okay. Now I know that's not normally always the case, but yeah, my go-to on that is actually um, roll forward rather than um, backwards. So let's jump back to the slide. So that's kind of my talk over and done with. I hope I hope everybody's taken something from it. It is quite it is quite of a beginner step into database deployments, and I understand that that was quite a simple quite a simple structure with a web app and a single database and a single table, and things can get a lot more complex than that. Um, but if anyone, apart from the questions that we have next, if anyone has any questions later today or wants to reach out to me to discuss their exact scenarios, let me know. We have plenty of experience here at Octopus in deploying database changes, so just reach out and let me know, and I'll try and help. So I'll move on to questions. I'll double check Slido. So there's no questions at the moment. So I'll hand over. Unless anybody's got any questions or wants to put in there now, and give that a couple of minutes. But if anyone wants to reach out to me later on in the day, just get in touch with me.